brightest star in our night sky is not alone. If you've ever looked up on a clear night and spotted one star shining brighter than all the others, you were probably looking at Sirius. People have admired it for thousands of years, building calendars around it and using it to guide their ships. But almost nobody realizes that right next to it, hiding in its glare, sits the crushed remains of a star that died long ago. It's so heavy that a single teaspoon of it would weigh about as much as an elephant. This is the story of Sirius B, the dead star hiding in plain sight. Sirius itself is a huge, brilliant star sitting about 8.5 light-years from Earth. It burns 25 times brighter than our Sun and is almost twice as massive. For most of history, people only knew about this one star. Nobody suspected a second hidden star was locked in orbit right beside it. The discovery came from mathematics, not a telescope. In 1844, an astronomer named Friedrich Bessel noticed Sirius wasn't moving in a straight line across the sky. It had a slight wobble, as if something invisible was pulling on it. He reasoned that only gravity from a hidden object could explain that wobble, and he predicted a hidden companion existed years before anyone actually saw it. It took until 1862 for anyone to find it. A telescope maker named Alvan Clark was testing a powerful new lens and spotted a tiny, faint point of light hiding beside Sirius's blazing glow. He had found Sirius B, one of the strangest objects ever seen at the time. It was so faint compared to its partner that finding it was like spotting a candle beside a lighthouse. Scientists soon discovered something shocking. Sirius B is roughly the size of Earth, but it contains almost as much mass as our entire Sun. Imagine squeezing the whole Sun down into a ball the size of our planet. That's exactly what happened here. This type of object is called a white dwarf, the leftover core of a star after it dies. The star that became Sirius B used to be even bigger than the Sun, maybe 5 times as massive. When it ran out of fuel, it swelled into a giant, blew off its outer layers into space, and what remained collapsed under its own gravity into this small, unbelievably dense core. The density is hard to imagine. A single teaspoon of Sirius B would weigh about 5 tons here on Earth. That's heavier than an elephant, packed into a spoon. If you tried to stand on its surface, the gravity would crush you instantly, far beyond anything a human body could survive. Sirius B isn't just strange, it's historic. Its extreme gravity was used to help confirm Einstein's theory of general relativity in the 1920s, proving that gravity can actually bend and stretch light itself as it escapes a massive object. This was one of the key pieces of evidence that helped prove Einstein was right. Here's the part that should give you chills. Billions of years from now, our own Sun is going to do the exact same thing. It will swell into a red giant, likely engulfing Mercury and Venus, shed its outer layers, and collapse down into a small, dense white dwarf almost identical to Sirius B. Every time you look at Sirius, you're looking at both the present and the future of a star at the same time. Sirius B and Sirius A are locked in a slow 50-year orbit around each other, one blazing brightly, still fusing hydrogen, the other silently fading, already finished with its life. It's a strange kind of cosmic mirror, showing exactly where a star's life is heading and what waits at the end of that journey. White dwarfs like this one never fully go dark either, at least not yet. Scientists believe it would take longer than the current age of the entire universe for one to cool down completely into a cold black corpse. That means every white dwarf we've ever observed, including Sirius B, is still slowly fading. A process that began long ago and will keep going for longer than we can truly imagine. There's also a limit to how much mass a white dwarf can hold on to before this balance breaks down completely. If one ever grew past about 1.5 times the mass of our Sun, usually by pulling material from a nearby companion star, it could no longer stay stable. The result can be a massive, violent explosion called a supernova. Sirius B sits safely below that dangerous limit, but it's a reminder of just how delicately balanced these dead stars really are. What makes Sirius B even more remarkable is how close it sits to us. Most extreme objects like this are discovered thousands or even millions of light-years away, visible only as faint smudges through the most powerful telescopes on Earth. Sirius B, by comparison, sits practically in our cosmic backyard, close enough that its pull on its companion star was detected using nothing more than 19th-century mathematics, and close enough that its faint light was captured by a telescope built more than a century and a half ago. Sirius B proves that even the brightest, most familiar things in our sky can hide secrets we never expected. But this is only the beginning. The universe still holds far greater mysteries. If this blew your mind, hit like, subscribe, and join us for the next cosmic discovery.